To finish up our exercise on notation set of sets, we're going to talk about whenever different sets, two separate sets of numbers or solutions or whatever we're dealing with, will either be combined together or have common elements, as we call them. So this is some basic definitions that you need to learn. So the first one is a union of sets, and so when we take two sets at a time, we basically take all the elements of one set and combine them together with those of the other set, we're said to have a union. And so you can see the U looking symbol, and that's just showing you that those two sets have been combined together. So you need to understand that definition and how that'll work. If we're talking about two different sets and they have elements in common, those would be the intersection of the sets, and so all the parts that are exactly the same would be the intersection of the two sets. Now sometimes the sets don't have an intersection, and so that's called an empty set, and the empty set is given with the 0 with the slash through it. Now we don't need brackets for an empty set, because in reality what it is it's acting like an empty set like this. So we have a bracket and we have a set bracket and there's nothing in there, and so it's empty, and so the empty set is denoted by the little 0 with the slash through it. So we would not put brackets around that. So let's take a look at sample problem number 3 and see how we would work this. Go ahead and pause it and try it on your own if you like, or you can just sit here and you simply watch for the example. So we know that on part A it says find A union B, which means we want to put together all of the elements from both sets. Now, it's traditional that whenever you put together a set of numbers, or whenever you write a set of numbers, that it should go from lowest to highest in increasing order. So we're going to start with A and B, and I'm just going to use a little marking system to mark it off. Now, we're going to start off with -6. Tends to be the lowest number here, so I got that one. Then we have a -5. Now if you notice here in set B we also have a -5. Since that's already represented in the set, it does not need to be written more than once, so technically that is already taken care of. We can see that a 0 is our next number, and then we say 1/3, 4, and then we could say 11, and then 17, and then you can see 17 is already written, so we don't need to do that, and so we've taken the union of those two sets. So that is a union. It's just a combining of the terms. Now I'm going to go ahead and erase this so I can reuse that information. This part B says to find the intersection of A and B, and so what we want to do at that point in the intersection is to find all of the terms that are the same. Well, we kind of figured that out a little bit when we were writing the union, because we said we did not want to write the same parts twice, and so we just need to go find those parts again. And so if we recall, -5 was common on both sides and 17 was common on both sides, and so we would simply write that as a set with -5 and 17. Intersection, set A and set B. Alright, now we're going to take a look at an intersection of parts B and part C, and it looks like I've failed to get set C in here, so this is a typo right here. So that right there is set C. Try that a little again, maybe a little better this way. So this is set C. So I apologize if that was confusing if you were looking at this before the video came out. So if we look at B and we look at C and we work our way across, there's no -6 in both, no -5. We have a 4 and a -4, that's clearly not the same. No 0, 17, 1/4, and so we can clearly see that B and C don't have the same any of the same elements, and so this set would be empty. It's kind of like having a set of brackets with nothing in it. However, that's not the way we write an empty set. The way we write an empty set is a 0 with a slash through it, and so we would choose this and not that. So that's how you write the empty set. Okay, well that's our brief lesson on intersection and union.